recommendation letters to write to. So, we started on this one. We started on silicon tetrachloride. And you're going to start hearing me naming things, because guess what comes next is nomenclature, and guess what's the next hard thing we're going to do is nomenclature, and guess what nomenclature is? A big fancy word of saying how we name things. So I'm going to start using that terminology so that you can hear it and get used to it. So we had made it to this point yesterday with silicon tetrachloride. And I had stopped and I said, I want to make sure, because I know that there are you in this room that are not going to look and go, how you get 32? I'm lost. I got no idea what's going on, Mr. Hall. And this is where I want to pause, and I want to make sure every one of you know how we're getting 32. So, let me get my periodic table up. Let's think about it. So going through and making sure we can count these. So this is how I start. I choose a starting point and I literally work all the way around it. So I'd like to start here. So I'd go 1, 2, 3, 4, 5, 6. That is not where I see students struggle. Where I see them struggling is, remember that the bonds count for 2 electrons. So this is 7, 8. Then I work down here, I go 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Because the bond counts for 2 electrons. 19, 20, 21, 22, 23, 24. Pop up here, 25, 26, 27, 28, 29, 30, 31, 32. Now I've counted all my electrons. I'm showing 32 electrons. Now yesterday I erased it. It's no longer on my board, but it's on your paper. How many electrons are we supposed to show in silicon tetrachloride? 32 electrons. Are we showing 32 electrons?
Yes, sir.
Yes. So this is kind of good. The issue here is I put all these numbers around on this thing. This is not a proper Lewis structure. If you feel the need to do this and actually write the numbers on the electrons, do it, but come out from it and actually rewrite the Lewis structure. Okay? This is what we're looking at doing here. I'm going to darken them in so you can see it on the video. Alright, so in this point we double check, we make sure that we have the proper number. In this case, the next step would be place double and triple bonds where needed. Do we need to place a double or triple bond in here?
No.
Why no? How do you know it's no?
Because you need 32 and you have 32.
Exactly. We have to show 32 and we are showing 32. When we're going to add those double and triple bonds is when those numbers are different and they're not matching. How about resonance? Is there a resonance structure here?
No.
No, there's not a resonance structure here. Why is there not a resonance structure here?
I'll be honest, I guess.
Somebody give me more than a guess. What was the key for resonance structure?
Don't you need a bond for that?
What type of bond?
Double bond?
And I combined an and and or there. Did you see that? You like that, didn't you? Come on. Come on. Double or triple bond. Thank you. You need a double or triple bond that can go in multiple places. That's the key. All right? Has to be able to go in multiple places. If it cannot go in multiple places, there is no resonance structure. I feel the excitement in the room. Y'all are just leaping with joy. Woo! How y'all feeling?
Is there a certain order you have to write those electrons down?
No, not in this.
I mean, like generally though.
The electron dot diagram, yes. When you're showing valence electrons. But in this, no.
Okay.
Later on, I guess technically there is a yes to it. Because it's like certain ones, you'll have it look certain ways. Like they'll take certain shapes. So, I want to work through one. We're going to step it up a little notch here. HCN. This is hydrogen cyanide. All right, walk me through it. Step one. How do we find the center atom?
Lowest electronegativity.
Lowest electronegativity except for hydrogen. Why not hydrogen? Is it only form a single bond, so it cannot be the center? So hydrogen cannot be the center between carbon and nitrogen. Which one is the center?
Carbon.
Carbon. Okay. Step two.
Draw the skeleton.
All right, let's draw the skeleton. The skeleton is literally just bonds out to the other atoms from the center atom. Everybody good there? Let's go step three.
Give everything a full octet.
Give everything a full octet. So how many electrons on hydrogen?
That would be
6. No.
1.
None.
8.
So y'all say
It's a single
8.
bond.
Oh, boy.
It's 0. It's a single bond.
0 is a single bond. Why? Because hydrogen is your first rule breaker. It will only fill the first subshell. It only has a 1s orbital it will fill. So it will only form one bond. I did this on purpose. This is a trick. I promise you, I'm going to throw hydrogen at you. Why? Because I'm going to watch kids go 1, 2, 3, 4, 5, 6. And I'm like, why are you giving hydrogen a full octet? Never give hydrogen full octet. Carbon
4.
needs 4. 1, 2, 3, 4. A nitrogen.
6.
Let's see. Why'd you get 6?
There's already 2 in it, inside.
Because there's 2 coming from the bond. 1, 2, 3, 4, 5, 6. 6 electrons. Ah, 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 ah.
How do you ever get 2 and 4?
Are you chopping that I'm getting 2, but there's 4 coming from these bonds?
Yeah.
Because only this bond is connected to the nitrogen. Now on this carbon, it's a really good question, Sonny. Thank you for reminding me. We have these 2 bonds connected to carbon. That's why we only gave 4 electrons to it, because it has 4 coming from those 2 bonds. All right, in this case, I forgot what step we're on, but next step,
Calculate the number of electrons you must represent.
calculate the number of electrons. Do your calculations. The first thing we do is we write down our elements we have. We have the hydrogen, the carbon, and the nitrogen. C?
C.
C. How many hydrogens?
One.
Uno. How many carbons?
One.
Uno. How many nitrogens?
Just one.
One.
Uno. Multiply that by the number of valence electrons for that element. Where do we find the number of valence electrons for an element?
The column thing.
The column it's in on the periodic table. So how many valence electrons for hydrogen?
One.
1. Carbon? 4 because it's in the 14th column. Nitrogen? 5 because it's in the 15th column. You guys are doing so great. I'm so proud. All right. We're going to do some math here. Okay? 1 times 1?
One.
Oh, y'all doing good. 1 times 4?
4.
Oh, yeah.
And
I believe in you. 1 times 5?
It's 5.
5! You're crushing it.
Add that all together and you get 10.
My goodness! They said the SAT is hard. You will crush it. You will destroy the math section. It will cry like a little baby to its mama. All right, how many electrons we got to show?
10.
10.
How many electrons can we only show?
10.
Let's count how many were. Did somebody say 4? The answer is 10. That's why we did that complicated math. It is 10. Let's count how many electrons we are showing. What?
Isn't there too many?
Yes. But we haven't counted it. Well, I haven't counted it. You've obviously counted already, but I'm going to count now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh my sweet goodness, we're showing 14. Can we show 14?
No.
How do we fix it?
We haven't done it yet.
I'm gonna be honest, I'm not sure.
We add. I thought I put it in the rule.
Add or subtract the overall charge.
Maybe.
Is there an overall charge?
No.
So we know adding or subtracting. Next, how do we fix it?
Use double, triple bonds.
Use double or triple bonds where needed to get this. So, let's do a double bond. Where are we going to stick a double bond? You want to stick it here?
No.
Why?
It's a
Single bond.
Well, there's a single bond there too. Why can't I stick a double bond here?
Hydrogen special.
You insult him. How dare you? He can hear you, you know. He's right here.
You'll get over it.
Okay, why is hydrogen special?
Can only form a single bond.
Only forms a single bond. So can I stick a double bond here?
No.
If you stick a double bond or a triple bond here on hydrogen, Mr. Hall will mark it wrong 1,000% of the time. So can we stick a double bond here?
Yeah.
Yay! Let's stick a double bond. Boom. Anything else got to do?
Yeah.
What?
Now there's 16.
Well, snap, I didn't fix anything. What's the problem?
Can you like erase 2 now?
Oh, hey, why would we do that?
Because you
It's a
added,
step in the right direction.
Okay,
because you added 2 electrons.
I added 2 electron, which means I'm breaking,
The bonds.
not the bond,
Yeah.
the octet rule. I'm breaking the octet rule. Look at carbon. How many electrons am I showing for carbon?
10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many can carbon show?
8.
Only 8. Carbon is not a rule breaker. So in that case, we have to erase 2 electrons. I'm going to erase the bottom ones.
Doesn't matter.
Are we done?
Doesn't matter which
No.
ones you can erase.
In this class, no. Later on, what you'll learn is like they'll take certain shapes and things. And I'll show you here in a second. Because it actually applies here. It applies right now as soon as somebody looks at me and tells me that I'm not finished, that I need to do something else.
erase 2 from nitrogen.
Why?
There's 10.
It's breaking the octet rule.
They're breaking the Octet Rule. There are 10 electrons. We cannot do that, so we must erase 2. This is how we fix things with adding double and triple bonds. As soon as we add that double or triple bond, we're adding 2 electrons, but we're taking 4 away. Unless you got a rule breaker, and then things get freaky. Don't worry, we'll do that later. Count it up. How many we showing now?
12.
Well, hot dog, we still ain't finished. What we do now?
Add another bond.
Okay, can I add one here?
No.
Why?
Because it's a rule breaker.
It's a rule breaker. It will
Only form a single bond.
only form a single bond. No double or triple bonds on hydrogen ever. Capiche? I feel like I've warned you multiple times on this. So where are we going to do now?
Put it on the nitrogen.
Add another stick and erase 4 electrons.
Add another stick right here, which makes this a what?
Triple bond.
A triple bond. And me done?
No.
Me no done?
9.
How me get done?
Erase
Erase what?
electrons.
From where?
2 from carbon, 2 from nitrogen.
Oh, okay, so what if I erase here? And this kind of answers your questions behind like what ones to erase. What are electrons? They're subatomic. They're negatively charged subatomic particles. I understand, yes, they can be a wave also. We're treating them as a particle. They're going to be a particle. So they're negatively charged. What do like charges like to do?
Repel.
Repel. So they're going to try and get as much distance away from each other as they can. So the most distance would be between these bonds and these two. So technically, I'll erase that right there, and you'll see me do that. Now, we should have done this here, but I didn't because I knew there wasn't one. I'm doing this now for your benefit. Last step, what we do?
Show charge and resonance structure.
Show charge. All right, let's look at the hydrogen. Let's figure out the charge on the hydrogen. How many valence electrons does hydrogen normally have? 1. How many is being shown for hydrogen right now?
1.
1. It gives me 0. I understand if you went 2, and this is why I did this. Remember, at this step, we mentally break this bond. 1 electron goes to hydrogen, 1 electron goes to carbon. Okay? You're doing good. Now is the time to make your mistakes. Later, you don't want to do that. All right, let's look at carbon. How many valence electrons does carbon normally have? 4 minus, how many am I showing now?
4.
4. Okay, because remember, we're going to cut these bonds in half. So 0 is neutral. All right, let's look at nitrogen. How many valence electrons does nitrogen normally have? 5 minus. How many are we showing now? The 5. Very good, Tatty. Very good. 0. So no charges. Is there anywhere else that triple bond could have went?
No.
Why couldn't it go here with hydrogen?
Rule breaker.
It's a rule breaker. It only forms a single bond. I'm going to like drill this into y'all. Done.
Amazing.
How do you feel?
The opposite of amazing.
What is that?
Horrible.
How is everybody? We okay? Yeah? See?
Feeling better.
I tell you what. You know what now is the perfect time for?
Bonus points.
Yes.
Get out of my room. You cuss at me like that. That's ridiculous. Sickening. Sick. It's time for me to make you acquainted with the most stable bond
Oxygen.
in the universe? Nitrogen. What's special about nitrogen?
It's everywhere.
It's like 97% of the air.
It's everywhere. It's not quite that much. But
It's
a lot.
Oh wait, no, it's like 75
It's a diatomic.
or something.
it's a diatomic. Thank you, man. You're making my day.
Good job.
When I say nitrogen, what do I say? N2, baby. Woo! I want you to try nitrogen as well as water. I believe in you. If you want to do the easier one first, do the water. Water is easier than nitrogen. Yeah? Okay? I believe in you. Do not get nervous. I'm going to walk around and look and see where you are, how your life is doing within my chemistry class right now. Follow your rules, child. You can do better than this. Follow your rules. This is the part where we go from you learning and mastering this. It's because you'll do it on your own.
You just had to throw nitrogen in there, didn't you?
Yeah. How many hydrogens you got?
That would be two.
I mean, you show it. You rob the bank, take two away. Very nice, very nice. Attempt this, attempt this. Do not just stare at a blank page. Blank page, no help you. How many hydrogens you got?
I was doing
What you show for? You rob the bank, take two away.
That's fine.
Hard? These are not hard.
Yep.
I've prepared you. Very beautiful, very nice. Are you done? Okay, keep following your steps, keep following your steps. Are you done? I feel like you're guessing, Dave. How many electrons you got on the oxygen? I mean, it's supposed to have. Stand for.
That's it.
Eight electrons.
We did it.
Are you done?
I don't know. I think I need to do something else. But,
What makes you think you need to do something else? Did you follow your steps? I gave you the steps. Remember I wrote them over on the board? I put pretty colors with it, with words. That's very
That's a
sad.
good one.
Okay, so step one.
I think that's it.
Find the center atom. You did it. You made it. Awesome. Very nice. Step two, you draw the skeleton. You did that very nicely. Step three, give everything a full octet. I'm very proud of you. You only gave oxygen the octet, not the hydrogens. Tricky, tricky I am. So at this point, we're doing good.
Yeah, I don't know that. No, I don't read it. I don't know this. I don't know.
Yes, you must check charge. Charge is important.
It's gotta be.
Once you check charge, you have no double or triple bonds, so there is no resonance.
I really don't know.
After you check the charges, the first charges, you gotta show charges.
That's it. Not so far.
So far.
Okay.
Y'all are so nervous, but you're doing so well.
Is it good? I don't know.
Oh,
No.
very nice, doing good.
Right here. You got your electrons.
We got the skeleton, that's a good point. You have the skeleton, you have the backbone.
To add them up on there.
Very nice, Thomas, very nice.
And the two lines equal
By the way, you can talk and help each other. They're totally fine, you are totally
so
fine.
that equals 2, that equals 2, so that's 4, so you gotta add one more dot to equal 8.
Why do you want to take away?
Why don't because hydrogen. Yeah, hydrogen.
That's right.
Always has to equal. Yeah. Because if it was a different letter, like, I don't know, you put 6 on the outside, because these two equal.
There you go. There you go. There you go. Y'all can get to it.
So, all you gotta do
It's actually
Okay. So this is not what we do. This is what these bonds in half. I say do it mentally so you don't have to rewrite it. One electron goes to the hydrogen, two goes to the oxygen. One goes to the oxygen.
The first number comes from
And
how
then
many
you
there are.
subtract how many you're showing
2 hydrogen.
from how
Or
many
you get stuck on.
how many valence electrons does hydrogen only
And you
have.
multiply by the column they're in.
So 1 minus, how many are we showing for this hydrogen right here? 1 minus 1 is
the electrons.
no charge. And it's the same thing on that hydrogen. So no charge.
How do you remember that?
How do you calculate the
What?
electrons?
Okay.
How do you get this?
It's gonna be the number, so it's gonna be the number of this.
Okay, so start the 6.
Take that and
Minus how many are we showing?
Subtracting out one.
That's gonna be to find the charge or the resonance.
The oxygen. 1, 2,
Find the electrons and multiply by the column number. Well, or, yeah.
6 minus 6.
Yeah.
0.
So it's 2 times 1 times 6.
It's not terrible. Yet.
So that's, yeah. Then you have
I'm actually feeling confident.
I like it. I like it when you feel confident.
Except for the.
Well, she's gonna come over here. No.
I'm not coming to crush hopes and dreams. That is very beautiful. That is very good.
Oh, okay.
That is very good. I like that. I like that also. You write very small. I apologize. I missed it. Okay, so how many of them you got? 2. So we need a skeleton. There we go. Oh, how many nitrogens you got? 2. So don't rob the bank. Only show 2. Yeah. Okay, you got your skeleton. What's after skeleton? Give everything full octet. All right. Moment of truth. The pressure is mounting. Did you do good?
Yes.
Or did you not do good? Let's start with the water. We'll start with water and go easy. Then I'll jump back to the nitrogen. Okay. So in this, center atom. What's my center atom for water?
Oxygen.
Why is it oxygen?
Hydrogen will never be the center.
Hydrogen can't be the center. Draw the skeleton. Next step,
Give everything the fall.
give everything full octet. How many does hydrogen need? Why?
Because it's only forms a single bond.
Only forms single bond. What about this hydrogen?
None. Same thing.
None, same thing, because this is still hydrogen. Only a single bond. What about the oxygen?
Full octet.
How many?
Give it 4.
4. Why 4?
Because the bonds are electrons.
The bonds are electrons, and I have 4 coming from the bonds. So 1, 2, 3, 4. Calculate how many electrons you can show and must show. How many hydrogens we got? 2. This is important, okay? How many oxygens? 1. How many valence electrons does hydrogen have? 1. So 2 times 1 is 2. Oxygen? 1 times 6 is?
6.
2 plus 6?
8.
8 electrons. So I have to show 8. Count it up. How many are we showing? 1, 2, 3, 4, 5, 6, 7, 8. We're showing 8 electrons. I can only show 8 electrons. I don't need a double or triple bond because those numbers match. Now, let's move to charge. How many valence electrons does hydrogen normally have? 1. So it's 1 minus how many valence electrons are we showing for hydrogen?
1.
Why are we saying 1 when there's a bond here?
Because you break it in half.
We break it in half. 1 goes here to the hydrogen, 1 goes over to the oxygen. 1 minus 1 is?
0.
0. 1 minus 1 is? 0. Y'all doing fantastic. That SAT that's coming, my juniors, you will do wonderful. And for my seniors, you will do great in college. I believe you. Now, look at the oxygen. We ain't done. Hold up. Oxygen. How many valence electrons does it normally have? 6. 6 minus?
6.
6, because we're showing 6. 1, 2, 3, 4, 5, 6. Remember, break the bonds. 1 goes to the oxygen, 1 goes to the hydrogen. 6 minus 6? 0. Any charges? No. That is your properly Lewis structure for your water. 4 nitrogen, so you have your answer before you get out of here.
Oh, I did it
Oh my
right.
God.
Oh yeah, that's easy.
That is the answer. If you have questions on it, we will pick up there tomorrow. And we're going to keep rolling with these. Tomorrow, I am done playing around. You are prepared and ready for the hard stuff. Now, I love you. Get out of my face. Go to your second period class and crush it.
I'm not going to be here.